For our next division situation, we're going to consider what it looks like to divide a polynomial by a binomial. The example that we're going to look at is actually an example that we're probably pretty familiar with how to solve. X squared minus 14x plus 24, all divided by x minus 2. Now, if you think back to previous strategies that we've already looked at in this lesson, you would think that there might be some kind of splitting you can do from the x minus 2. Maybe split the x to go with the x squared and the 14x, and the 2 to go with the 12. Unfortunately, that's not a reality for us. We do not want to break up the denominator, as that grouping must be used together, x minus 2, to do a division on x squared minus 14x plus 24. When I mentioned earlier that this was a division that you were probably familiar with, it's probably because you recognized or clocked from the very beginning that this polynomial factors to x minus 12 and x minus 2. Logic would then tell you that if this was our divisor, we could simplify the x minus 2 with the x minus 2, and we would get an answer of x minus 12. But what if we weren't able to see that division from the very beginning? Or in some cases, what if that factorization didn't exist? We have an alternative for situations like this that we're going to use that's called polynomial long division. It's going to feel a lot like regular long division, except it's going to use polynomials and variables and the kind of work that we've been doing for the last few lessons. Polynomial long division works in a really simple format. We're going to look for a division. We're then going to follow that division with a multiplication. We're going to follow that multiplication with a subtraction. And then in regular long division fashion, we're going to bring down. So let's look at what this division looks like if we wanted to do it long division wise. X minus 2 is our divisor, so it goes outside of the polynomial x squared minus 14x plus 24. Right now, this should not look any different than normal long division. We have a divisor on the outside and the dividend on the inside, and we're going to look to see how many times does that divisor go into that dividend. When you do polynomial long division, you begin by looking at the dominant term on the outside and how many times does it go into the dominant term on the inside. So we're going to begin by looking at how many times does x go into x squared. Or, said another way, what do you need to multiply x by in order to get x squared? And a little bit of careful algebra tells us that that's an x. That is the division step in the polynomial long division. We follow that division step with a multiplication step. And that multiplication step takes that part of the quotient, the x, and multiplies it by the divisor. X times x is x squared. X times 2 is negative 2x. That was the multiplication step. We then move to the subtraction step. The subtraction step tells me to subtract that original polynomial by those two terms that I just created from the multiplication step. When I do that subtraction, as you might expect, the x squareds will go away. Negative 14x minus negative 2x, you want to be very careful with your signs here. Negative 14x minus negative 2x turns into negative 14x plus 2x, and the result of the subtraction is negative 12x. The last piece is to bring down the term that's left over. So in this case, we're going to bring down the positive 24. And we repeat the process again. We look at the dominant term of the divisor and the dominant term of the new polynomial that we created. What do I need to multiply by x in order to get to negative 12x? That's minus 12. I multiply the two of those together. I multiply this negative 12 by the divisor to create my next line. Negative 12 times x is negative 12x. Negative 12 times negative 2 is positive 24. I'm going to subtract that as my next step. And I'm going to end up with 0 as the result. There's nothing else to bring down. I brought down the last term of the original polynomial. So our final result is this is the quotient from dividing those two polynomials, which is exactly what we expected when we looked at the factored form. The way we write this is simply just the polynomial divided by the binomial equals the quotient that we got. In the case of this long division, there's no remainder.